Section 11.3, perimeter and area of similar figures. If two polygons are similar, with the lengths of corresponding sides in the ratio of a to b, then the ratio of their areas is a squared to b squared. So in the first example, we're told that figure 1 is similar to figure 2. So we want to find the ratio of their perimeters. The ratio of perimeters is just the same as the ratio of corresponding sides. So we're going to do figure 1 to figure 2, which is 18 over 10, and then we can reduce that to 9 over 5. To find the ratio of their areas, we're going to take the ratio of their corresponding sides, which is the same as the ratio of perimeters, and we're going to square it. And that's going to give us 81 over 25. In the next example, we're painting a ceiling of a bedroom in a den, and we need 7 quarts of paint to paint the larger ceiling. How many quarts do we need to paint the smaller ceiling? So first what we're going to do is we're going to find the ratio of the corresponding sides. I'm going to do larger to smaller. Since we have the larger information, we want to find the smaller. It doesn't really matter which order. I'm going to reduce this to 7 over 5. Since I need the area to determine how much paint I need, I'm going to square my ratio of sides to find what my ratio of areas are. So 7 squared is 49 over 5 squared is 25. Now I'm going to take that and use that to find how much paint I need. For the larger area, I'm going to use 7 quarts of paint, and I want to find out how much I need for the smaller area. I'm going to cross multiply to get 49x equals 25 times 7. And then I'm going to divide both sides by 49. And I get x equals 25 over 7. And then that would be my answer. So then that would be choice D. In the next example, we're going to use our ratio of areas to help us find a side length. So we have a small screen, flat screen TV is 24 inches wide and 18 inches long. The larger TV is similar to the smaller one, and it has an area of 657 square inches. And we want to find the width of the larger TV. So we're going to start with the information we know. We have the area of the larger TV, and we can easily find the area of the small TV because we have the length and the width. So it's going to be 24 times 18, which is 432 square inches. Now we can compare our ratio of areas. Our area of our smaller TV is 432 square inches, and the area of the larger TV is 657 square inches. We can reduce that to 48 over 73. So now that we have our ratio of areas, we have to think about how we can use this to find the width of the larger TV. We know that the ratio of areas is equal to the ratio of sides squared. So if we take the square root of 48 over 73, we will find the ratio of sides. And if I know that that's my ratio of sides, I can use the width of my small TV, which is 24, and solve that for the width of my larger TV. So I'm just going to go ahead and write these as 2 separate radicals. You do not need to do anything on the calculator. You don't need to find out what these radicals are. We'll get our answer at the very end. So I'm going to cross multiply. 24 times the square root of 73 equals w times the square root of 48. And then we're going to go ahead and divide by the square root of 48. Now we're just going to put that into our calculator to get our approximate answer. And we find out that our width is going to be 19.46 inches. So if you have 2 regular polygons that have the same number of sides and all the angles are congruent, the lengths of all pairs of corresponding sides are in the same ratio. Any 2 such polygons are going to be similar polygons. And then also, any 2 circles are similar. So all circles are similar with each other. So this last example, we have the pentagon in Washington, D.C. is a regular pentagon. Each side of the base is 900 feet. And then the area of the base is 1,400,000 square feet. We have a scale model for which the perimeter of the base is 30 yards. And we want to find the area of the base of the model to the nearest square yard. Since we want to find square yards, we're going to change these original values here into yards. So to change 900 feet to yards, I know that 1 yard is the same as 3 feet. So that's going to be 300 yards. To change from feet squared to square yards, I have to basically multiply 1 yard over 3 feet times 1 yard over 3 feet, or 1 square yard over 9 square feet. So this would be 1,400,000 over 9. And I'll just leave it like that for now. So now that I have these in terms of yards and square yards, I'm going to go ahead and start figuring this out. So if each side of my base and my actual pentagon is 300 yards, the perimeter of the pentagon base is going to be 300 times the 5 sides, because the pentagon base has 5 sides. And that's going to equal 1,500. So now I know my ratio of sides. I'm going to take my pentagon over my model. So that's the ratio of perimeters, which is the same as the ratio of sides. And I'm going to square that. That's going to be equal to the area of the actual base over the area of my model. And then when I go ahead and compute this through cross multiplying, I get that the area of my model is about 62 square yards.